about to discuss about bond energy or bond dissociation energy. So what is the bond energy or bond dissociation energy? The amount of heat energy required to dissociation of one gaseous bond into separate gaseous atoms. Okay, here amount of heat energy required to for dissociation of one gas bond into separate gaseous atoms is called bond energy or bond dissociation energy. Okay, so here bond energy or bond dissociation energy are the endothermic process. It is endothermic process. That means del H equal to positive. Okay, here one gaseous bond dissociation into separate gaseous atoms. For example, H2 gas dissociation to 2H. So del H equal to, this is bond dissociation energy. For example, half H2 to H. Here bond dissociation energy does not takes place. Okay, for example Cl2 to 2Cl, here bond dissociation energy takes place. For example half Cl2 to Cl, here bond dissociation energy does not takes place. Next HCl, here HCl gas, HCl is a gas. Here bond dissociation energy takes place H plus Cl. Okay, here bond dissociation energy takes place. For example, same HCl dissociation as a H plus Cl minus. Here bond dissociation energy not takes place. So we do not consider for bond dissociation energy. Bond dissociation energy means the gaseous bond dissociation into separate gaseous atoms. That's why this is called bond dissociation energy. Okay, next one. For a chemical reaction, A plus B gives rise C plus D. Okay, so bond dissociation energy equal to bond energy of reactant minus bond energy of product. For a chemical reaction, balanced chemical reaction, enthalpy of bond energy equal to bond energy of reactant minus bond energy of product. So total thermodynamics, enthalpy of combustion and bond energy only, reactants minus products. Remaining all parameters, products minus reactants. Remember this point, Amma. Only enthalpy of combustion, enthalpy of bond energy only for a chemical reaction, reactants minus products. Remaining all are products minus reactants. Okay na? Next, average bond energy, another formula. Average bond energy. Average bond energy equal to total bond energy required for dissociation of gas bond by number of gaseous bonds, number of gas bonds dissociation, number of gas bonds dissociation. This is average bond energy. Del H average bond energy equal to total bond energy required for dissociation of gas bond by number of gas bonds dissociation. Simply, total bond energy by number of bonds dissociation. Okay, this is average bond energy. Now we have to write down one sum. You have easily understand. One sum, right? Given the bond energies of N triple bond N comma H bond H comma N bond H are the N bond H are the 945 comma 436 comma 391 kilojoules per mole. The enthalpy of reaction is N2 plus 3H2 gives rise to NH3 is. Okay, so like that given we have to find out enthalpy of bond energy for that particular reaction, right? Now first you have to write reaction N2 plus 3H2 to NH3, N2 plus 3H2 to NH3. Here N2 means N triple bond N, H2 means H bond H, NH3 means N bond H. Okay, now enthalpy of bond energy equal to bond energy of reactants minus bond energy of products. Already we know. Reactants, which one? N triple bond N. That's why 1 N triple bond N plus 3H2. H2 means H bond H. 3 H bond H minus, okay, bond energy of reactants minus bond energy of products minus here NH3. How many bonds is there, NH3? 3 NH bonds is there. But again 2 NH3 is there. Minus 2 into 3 NH bonds. 3 NH bonds. 2 into 3 NH bonds equal to. Okay, this is like that we have to follow 1 N triple bond N plus 3 HH bonds minus reactants minus NH bonds. How many? 3 NH bonds. NH, NH, NH. 3 NH bonds. How many molecules of ammonia? 2. 2 into 3 NH bonds. Now value substitute N triple bond N. 945 plus V1 equal to answer. Okay, so like that we have to calculation of bond energy problems. Okay, yesterday question paper, your daily test question paper, one question came about bond energy, regarding bond energy problem. That problem we have to solve it. If at 298 Kelvin the bond energies of CH comma C single bond C comma C double bond C and H bond H respectively are values given 414, 347, 615, 435 kilojoules per mole respectively. The value of enthalpy change for okay, so ethylene hydrogenation they given CH2 double bond CH2 plus H2 gives rise C2H6. This is the question right. Ethylene hydrogenation, ethane coming they given CH values, CC values, C double bond C values, H bond H values they given. We have to find out the value of del H for this particular reaction. Okay, now enthalpy of bond energy equal to bond energy of reactants minus bond energy of products. Here CH2 double bond CH2. Before that we have the dissociation, means you understand this there. See, CH2 double bond CH2. Here CH2 double bond CH2 equal to 1 C double bond C is there, 1 C double bond C is there. Next to C, otherwise you write like that. CH2 double bond CH2. Now understand. 1 C double bond C is there. 2 CH2 2 CH2. 4 CH bond C is there. 4 CH bond C is there. Next here H2 means HH bonds like that. C2H6 means next this is over. C2H6 means C single bond C, H, 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 H. 1 C single bond C is there, 1 C single bond is there. CH, 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 CH. Totally 6 CH bonds is there, 6 CH bonds is there. Okay. Now write enthalpy of bond energy equal to bond energy of reactants minus products. First ethylene. How many C double bonds is there? 1. So 1 C double bond C, 1 C double bond C plus how many CH bonds is there? 4 CH bonds is there. 4 CH bonds. 4 CH bonds plus 1 hydrogen bond hydrogen. So 1 H bond H. Reactants over. Reactants part over. So bond energy of reactants minus products. C single bond C, how many is there? 1. 1 C single bond C plus CH bonds how many? 6. CH bond 6. 6 CH bonds equal to. Now the value substitute. Del H of bond energy equal to C double bond C value how much? 615. So 615, 1 into 615 plus next CH bond value 414. So 4 into 414 plus 27 plus C bond H value 414. That's why 6 into 414 equal to answer. Like that you have to do calculation of bond energy problems. Okay? You have to do like that. Next. Next. Water molecule. HOH plus 112 kilojoules of heat energy taking. This is like that endothermic amount. Gives rise HO plus H. HO plus H. This is endothermic only amount. Left side we write plus 112 kilojoules means endothermic only. Already we discussed in heat of reaction. Next. HO plus 108 kilojoules gives rise H plus O. What is the average bond order? What is the average bond energy? Okay. Then now average bond energy equal to what is formula? Total energy required by total number of bonds dissociated. Total energy 112 plus 108. 112 plus 108 by here HO between HO to H one bond breaking here. Here between H to 1 here this bond breaking one bond. Next here second bond. Total bonds dissociation 2. You don't count total number of bonds total number of bond dissociation we want. We don't need it how many bonds present in that particular molecule. We don't need it. How many bonds dissociation we need it. So here one bond, here one bond, two bonds dissociation. That means 220 by 2, 110 kilojoules per mole. Okay, this is the about bond energy. Okay, simple concept only. So you also practice 4-5 problems in your reference books. You can easily understand. Okay, this is about bond energy. Next one, the small enthalpy is there. Heat of hydrogenation. Heat of hydrogenation. What is heat of hydrogenation? The amount of heat evolved. The amount of heat evolved. 1 mole of unsaturated compound converts to the saturated compound. Otherwise, 1 mole of heat energy evolved. 1 mole of unsaturated compound hydrogenated to saturated compound. That is called heat of hydrogenation. So here 1 mole of unsaturated compound hydrogenation saturated compound. This is exothermic. Heat evolved. Exothermic. Heat energy released. For example, CH2 double bond CH2 plus H2 C2H6. Okay, del H equal to negative. Next, CH triple bond CH plus 2 moles of H2 C2H6. So exothermic. Next, CH triple bond CH plus H2 CH2 double bond CH2. Here heat of hydrogenation does not take place. What is the reason? Compulsory heat of hydrogenation. Unsaturated compound converts to saturated compound. Here acetylene alkyne unsaturated, ethyl ethylene also unsaturated. Unsaturated to unsaturated, we do not consider for enthalpy of hydrogenation. When we consider unsaturated compound converts to the saturated compound only, we have considered heat of hydrogenation. This is exothermic process. Next, heat of atomization. Heat of atomization. Heat of atomization. Okay, what is the heat of atomization? The amount of heat energy required. The amount of heat energy. The amount of heat energy required for one gaseous substance into their gaseous atoms. One substance dissociation into their gaseous atoms. That is called heat of atomization. So heat of atomization means amount of heat energy required for substance dissociated into substance, 1 mole of substance, 1 mole of substance dissociate into gaseous atoms. That is called heat of atomization. Heat energy required. This is endothermic process. Heat of atomization is endothermic process. Okay, heat of atomization is endothermic process. Amount of heat energy required for 1 mole of substance dissociation into gaseous atoms. Okay, now 2 gaseous atoms. That is called endothermic. This is endothermic process. Okay, next one. Heat of hydration. Heat of hydration. So what is the heat of hydration? So the amount of heat evolved, anhydrous crystal. Anhydrous means without water. Anhydrous means without water. Amount of heat evolved, anhydrous crystal react with fixed amount of water molecules. That means sufficient water molecules. So anhydrous crystal react with fixed amount of water molecules to form specific hydrous crystal. That is called heat of hydration. This is exothermic process. Del H equal to negative. Okay, anhydrous crystal. For example, CuSO4. This is anhydrous crystal. Okay, react with fixed amount of water molecules. 5 moles of water. So CuSO4 5H2O. This is hydrous crystal. Hydrous crystal means crystal with water. So crystal with water. This is exothermic. Heat energy released. Del H equal to negative. Okay. Next, MgSO4, magnesium sulfate. This is also anhydrous crystal plus 7 moles of water. it gives rise MgSO4 7H2O. Here enthalpy change equal to negative. Okay, so this is about the heat of hydration. Okay, totally enthalpy, heat of formation, heat of convection, heat of hydration, heat of bond dissociation energy, heat of neutralization. Another one, heat of transformation is also there. Simple one. Heat of transformation means already entropy topic come. Enthalpy of vaporization, liquid converts to vapor. Liquid converts to vapor. Next, enthalpy of sublimation, solid converts to the gas. Next, enthalpy of fusion, solid converts to the liquid. These all are called heat of transformations. Okay. Now, heat of convection, heat of convection, heat of hydrogenation, heat of hydrogenation, heat of hydration, heat of hydration. Next, heat of neutralization, heat of neutralization. All these parameters are exothermic. All these parameters are exothermic. Enthalpy equal to negative. Okay, all these parameters are exothermic. Enthalpy equal to negative. Next one, bond dissociation energy. Okay, bond energy, heat of atomization, heat of atomization, heat of transformations, heat of transformations, heat of transformation. That means already you know three transformations. Heat of transformations, three. Fusion. Fusion means solid converts to liquid. So solid converts to liquid. H2O solid converts to H2O liquid. Fusion. Next, vaporization. Enthalpy of or heat of vaporization. Vaporization. H2O liquid converts to H2O vapor or gas. Next, third one, sublimation. Sublimation, heat of sublimation. That means solid converts to directly gas. Solid converts to gas. Okay, all these are endothermic. All these are endothermic. Okay, del H equal to positive. All these are endothermic. Del H equal to positive. Next, heat of formation, heat of formation or enthalpy of formation, del HF, comma, heat of solution, heat of solution. Heat of solution means crystal converts into crystal dissolved in a large amount of solvent. Okay, further how much solvent you can add, the heat energy does not change. So that heat of solution may be endothermic or exothermic. Okay, heat of formation, heat of solution. These both are endothermic. exo. Endo or exo. So del H equal to positive or del H equal to negative. Heat of formation, heat of solution. Maybe positive or negative. Okay, so in exam direct question coming amma. Heat of solution, what sign? Heat of hydration, what sign? Bond dissociation energy, enthalpy equal to what sign? So direct questions coming in NEET exam. That's why you should remember these parameters. Okay, heat of solution. 1 minute, listen. So before I didn't explain, heat of solution. Heat of solution. Del H solution. Heat of solution means the amount of heat energy released or observed. That means maybe exothermic or endothermic. Whether exothermic or endothermic. Okay, the substance crystal. Here substance means crystal. Crystal dissolved in large amount of the solvent. Crystal dissolved in large amount of the solvent. Further, how much solvent you can add, heat change does not take place. That means further how much solvent you can add, heat energy change cannot take place. Okay, heat remains constant. That is called heat of solution. Okay, heat of solution means whether endo or exo, heat energy released or observed. Whether endothermic or exothermic, crystal dissolved in large amount of solvent, okay, large amount of solvent. Further, how much solvent you can add, heat change does not take place. Heat change does not takes place. That means remains constant. This heat of solution may be endothermic or exothermic. Endothermic or exothermic. Okay, this is heat of solution. Example MgSO4 plus 7H2O plus aqueous solvent gives rise MgSO4 7H2O aqua. This is heat of solution. Okay. Heat of hydration, heat of solution difference observed. For example, CuSO4 plus 5H2O gives rise CuSO4 5H2O. This is heat of hydration equal to negative. Next, see CuSO4 plus 5H2O plus aqua, large amount of solvent. Then CuSO4 5H2O aqua. Okay, this is maybe positive or negative. Next, for example, MgSO4 plus 7H2O gives rise MgSO4 7H2O. This is enthalpy of hydration equal to negative. Same reaction, MgSO4 7H2O plus aqua. So MgSO4 7H2O aqua. This is enthalpy of solution, whether positive or negative. This is difference between heat of hydration and heat of solution. So in NEET exam representations also asking some reaction they won't given belongs to hydration or solution. Some reactions they given. For example, H2 dissociation to 2H, half H2 dissociation to H. In these two reactions, where is heat of atomization takes place? Heat of atomization means gaseous atoms. H2 dissociation to H only heat of atomization takes place. Half H2H means heat of atomization does not take place. That's the representation reaction. Then you should be learning stable standard state of elements. Okay. Like that theoretical questions also in reference books you have to practice. Okay, not only some theoretical questions, reaction representation. So elements, standard and stable states, everything you have to practice. That only 100% you can able to solving question in thermodynamics chapter. Okay students, thank you.